Great to be here, so excited. I'm loving this room layout because it feels like I'm in the most intense job interview in my life. So, yeah, feel free to ask me any questions. So what I'm going to propose to set the context here is a joke, which goes as follows. Has anyone heard of the band Clipping? No? They're a experimental hip-hop group. And I was thinking of starting my own band, and I was going to try and reproduce their results. Yeah. So what we're talking about here is reproducibility. Okay, so that's what we're going to talk about. Just as a hands up, who has heard of Nix? Yes, very exciting. Great. So of course we're going to start with like packaging 128 programming languages. You know, maybe we should start with what is a programming language, but obviously we're not going to do that. We're just going to start with what is a quine. So who has heard of a quine? So more people know about Nix than quines. There's some overlap. Does anyone want to describe what a quine is?
Maybe.
Please.
It's a program that when you execute it, it outputs its source code.
Lovely. Yeah, exactly. So does that make sense to people? Any questions about that? So here's an example. Right? This is a Haskell program that when you run it, the output is the Haskell program itself. Right? Is that interesting? It is pretty interesting, right? I have to say, when I first encountered programming, I wouldn't have thought this was possible, right? So I think this is pretty cool, right? There's actually a really nice little article there about how to write lots of quines, so in various different languages, so you can have a look at that if you like. So maybe you caught that actually what we're talking about is a quine-relay. So who wants to guess what a quine-relay could be?
I can.
You, please.
So I saw the image you shown, but the quine-relay is like you do quine, but you pass through many languages. So language A outputs language B, and language B outputs language C, and then you go back to the source code of language A. Lovely.
Exactly. Okay, so maybe you start in Python, you emit JavaScript, the JavaScript emits Rust. The result of the Rust is the original Python program.
Is it like a self-hosted compiler?
I don't know. In what sense would you feel it's a self-hosted compiler?
It's like you're rewriting the code in its own language, right?
Yeah. Perhaps you could. I think maybe the trouble with quines, like as was kind of evidenced on that first slide, is they tend to just be like encoding, like they're not doing anything necessarily complex other than encoding kind of string representation rules, kind of. But yeah, I think it's a nice thought. Any other thoughts? Cool. All very clear so far. Right. Good. Okay, so now...
Doesn't it mean why not in Latin as well?
Does it? Could do. I'll take your word for it, that it means why not in Latin. Anyway, so the point is like doing that maybe 3 times, like through 2 different languages is interesting. Now do that through many different languages. And that is indeed this program, which is this. Does anyone know what language that's in, out of interest? there's no way. What, do you care to hazard a guess?
I'm not sure.
Yeah. So this, indeed, this is the entire source code. Yeah?
Can you please zoom in?
If
you ask him what is the program,
I don't think I can zoom in, but the first statement there is eval.
Bosch?
It's in fact Ruby. So yeah, this is indeed a Ruby computer program that will emit a subsequent 127 programming languages. Make sense? No. Yeah, seems crazy. Seems crazy. Yeah, I agree with you. It seems absolutely insane that you could even imagine that this is possible. Okay, so what are some natural questions you might have if you would hear about this project?
What for?
What for? Why? Any other questions people might?
How are variables sorted out?
Yeah, variables. Yeah. What do you mean by how a variable is sorted out?
Like Python and Rust and Go handle variables in different way, or arrays or linked arrays.
Totally. Totally. Yeah, it feels like there's a mountain of intractable problems, right? Questions I had is like, well, is the programming language I care about in this list, right? Maybe, hopefully, right? The next obvious question I had is like, how can I add a new language? Like 128 doesn't seem like enough, right? There's probably more programming languages than that. And actually, something that I was really excited about is I wanted to see the source code for some particular language, right? I don't know if maybe this is a very odd question, but does anyone have a programming language that they are desperate to see a certain program written in?
Absolutely.
Closure. Closure, yeah. Yeah. Anyone else? Any?
When you saw it once, you cannot unsee it. Like it's just for the rest of your life. I was interested in the topic, like, and as I said, you cannot unsee it after that.
Yeah. Of the quine itself. Yeah, exactly. So, annoyingly, answering some of these questions involves running the system yourself, right? Now, well, that's easy, right? You just go to GitHub, you clone it, and you run the README instructions for the Docker image, right? And it just works, right? No, it never works, right? It obviously doesn't work. It didn't work for me, right? And it never ever works, right? So this is just some random Docker error I got. To be fair to it, step 44, so it made some progress. And I don't know if anyone actually remembers this project from back in the day. If I recall well, I think this was first put out in 2013 with 50 languages. So it's like, if you go back in time 13 years, you've almost made it, right? You're up to language 44. Yeah, so what I would ask is like, have you ever seen README instructions fail?
Yes.
IKEA. Yeah, it's very annoying. Anyone else seen instructions fail? Yeah. You're saying no, never in your life. Always works perfectly. Yeah. So my proposal is like, what if it always worked? Wouldn't that be cool? So, Nix, does anyone want to hazard a guess or proffer an opinion of what they feel Nix is?
A reproducible tool with no documentation?
Love it. A reproducible tool with no documentation. That's a fantastic observation. Any other proposals?
Well, it's a language, it's a package manager, it's many things.
Exactly. A language, a package manager, yeah. Anything else? No, this is very exciting for me personally because I think like often in my life when I talk to people about Nix, the first thing they say is Nix is very annoying. But like I haven't heard that here, so that's great. That's great news for Nix. I'm going to tell everyone. So yes, is it a package manager? Is it a build tool? Is it a programming language? Is it an operating system? Are you looking at the operating system right now without knowing it? Now you know it. Is it a restaurant in Portobello? Could be, right? Yeah, so let's have a quick look. Who would like to tell me the name of a computer program? I'm ready.
I'll say.
CalSay. Do I have CalSay? I don't have CalSay. Okay, this is lovely. So now I'm going to try and spell CalSay. CalSay. Oh, I have to say something. Hello. Do I?
Control D.
Control D. Thank you for teaching me about CalSay. Right? The thing you're supposed to observe is that I did not have that program on my computer. Okay? And now I've obtained it. Isn't that amazing? Right? So what I want to show you is that came from here, where they have many packages. Questions? That was pretty cool, I think. So what I want to show you is I just demonstrated using Nix as a package manager. Agree or disagree?
Agree.
Agree. Lovely, thank you. That place that I got the packages from is called Nix Packages. That'll turn up in a little bit later. Nix is also, as our friend there pointed out, a programming language. In my opinion, this is the least interesting and arguably most annoying fact about Nix. This programming language is probably widely hated. It is indeed an operating system, but actually it just is a way of distributing the Linux kernel. And so I seriously doubt anyone cares, but I am running NixOS here, and you can see that it is for the presently working. Yeah, so we're still having a look quickly. What I wanted to show you was it is also, I mean, maybe this is obvious of any package manager, but it is also a way of constructing packages, right? Maybe that may or may not be obvious. So actually we can see that with CalSay, probably. Oh, by the way, FYI, new version of CalSay in Go. So you can look here, and this shows you the Nix code that they use to construct the CalSay package, right? Does that make sense?
Could you zoom in a bit?
I can definitely zoom in, yeah. So the main point is you kind of you obtain it from GitHub, you kind of use make to build it, and then you do a bunch of busy work, right? And if you get excited about Nix, busy work is your life. Yeah. Questions? Yes.
What stops a Nix package breaking when, or compared to a Docker image, Docker file?
Lovely question. Yes. What stops a Nix package breaking? Very good question. I suppose it's ultimately about the way the build system is structured is so-called pure and kind of designed to be reproducible. One thing you might observe here is that it is talking to GitHub, but it has a constraint on what it expects the result to be. And that's that hash. So when it downloads that file from GitHub, if it's not the file that it expected, it will just cease to operate. And so that's a kind of ensuring of consistency. Yeah. You mildly satisfied? Yeah. How do you feel about that answer?
It's not only the source, but it's also all the inputs you give to this package. So you have maybe make to make the program, and so maybe you use some version of make, and this version of make is baked into the package. And so if tomorrow you change this version of make, you have to remake this package. And if you want to make this package in 10 years, you just check out to this file, and it knows what version of make to use, and so it will use the right version. And if it works at some time, it should work in 10 years, because you have all the description of the build tools you used and the version you used for this build tools.
Yeah, exactly. Yeah, so exactly. Lovely point. That's expressed here with these. These are kind of arguments to this Nix function, if you will. Yes, please.
Yeah. And also, like, everything is built in a separate environment, so they don't have access to build tools you may have installed. So usually in like a classic project, you may have instructions for like a sudo apt install some packages, and you may have a bunch of libraries lying around. But with Nix, because it's packaged externally or in some other containerized place, you are sure that you have specified all the inputs to your package.
Right.
And you are sure you are not missing any.
Exactly, yeah. I think we'll come to that in a little bit, yeah. So it's about the inputs being kind of pre-specified and fixed by, in Nix package, a commit hash. Yeah, and other things related to this kind of so-called sandbox. So what I wanted to show you, like I didn't have to run cowsay that way out of interest. I could have run it like this. Nix packages hashtag cowsay. The reason I made that point is because I wanted to show you that actually that thing that I did first of all was make a kind of a shell where I have particular programs available. And you can see that here. I think on my computer I don't have Node at all. I choose not to install JavaScript. If I go here into this folder, I do have JavaScript. And so this is kind of showcasing this concept that Nix calls dev shells, right? We're not going to go too deep into that, but I just wanted to kind of show you an example of that.
What happens if you give it a null string to C?
To what? A null string to what?
To cowsay.
Oh, to cowsay. Yeah, we could find out. What's a null string? Like that?
Double quote, yeah.
Oh, no. Let's do it correctly.
Minus C or something.
Cow says nothing. There we go. Learned something about cowsay. So, yeah. So I wanted to give like a little bit of an overview about the theory of Nix, and you kind of saw a hint of this, which is like maybe the first time you encounter Nix packages, you feel it's a little bit magical. As you saw when I go on search.nixos.org, I can view the source. You see that it's basically a collection of kind of trivia about how to configure packages. And I think that fact is expressed very well through that picture. So Nix consists of derivations. We've actually already seen one. It consists of this thing called the Nix store, where it stores all of its artifacts related to its builds. It, as our friend here pointed out, it also has this so-called sandboxing, which is really what ensures that all builds are completely reproducible because all the inputs are specified and so on, aside from this kind of little escape hatch of this so-called fixed output derivation, which, so typically these builds can't connect to the internet unless you can provide me a hash of what you're going to get back from the internet. And this turns out to be really useful. It won't shock you, almost everything you need to do development comes from the internet, right? So you often need to be downloading things, and certain build tools do calls out to the internet. So that tends to be pretty handy. And you'll see that this kind of so-called content-based hashing has huge benefits in terms of like build times. Because if something has not changed, then there's no need to rebuild it. Like if you can merely compute the hash of something and find that it hasn't changed, there's no reason to recompute it. Does that make sense? Yeah. Any questions about that?
So does that mean that the Nix store directory is global, and if cowsay needs make and figlet also needs make, and it's the same make, that make binary is in Nix store by hash?
Lovely question. Yes, indeed, one of the biggest benefits of Nix is caching. And so indeed, if two separate builds rely on the same version of something, you can just reuse that version, and that is like huge, and also the reality is essential, because without having that, you can't do practical Nix development, I think, in the modern age.
I have a question.
Yes, please.
What happens if the hash of some root 2 will change? For example, you have like a dependency, like a really long dependency tree, yeah? And like some root node, which is like very high hierarchy, and change its hash, it should rebuild all the tree, yeah?
Yes. Yep. But notably, you don't kind of accidentally express, like a classic dependency problem you have on computers is that like you have two Python things relying on some version of some system library. You update the version of the system library, it breaks one, it doesn't break the other. That's because you made a classic mistake of not explicitly declaring your input dependencies, right? Which you don't make that mistake in Nix typically. So indeed, it kind of does force a rebuild, and it should force a rebuild, because that's exactly what you requested by using a new version. Does that make sense? Good. Yeah, any more? No. And another thing that like I personally feel, I don't know if anyone else feels this, but I think this kind of like immediate rebuild saves you from a very special kind of Docker hell that probably a lot of you have experienced, right? When you want to rebuild your Docker image, it takes an obscenely long time, even though you know that it doesn't need to do certain rebuilds. The Docker experts in here will be going like, not if you get your layering right? And you can make a good effort to do that, but it's still, what I would say is like, it has a kind of user error that Nix doesn't have, right? So has anyone experienced that kind of Docker frustration, Docker-based development? Maybe. you're thinking back into your past days and years, and it's like, was Docker annoying to me? I don't know. Yeah. Oh yeah, and apparently I was going to show an example of this. I do have an example, right? So it's a little bit subtle, but we'll have a quick look. So I actually made so I made a Python example here. I think I've got like a test. Right, I'll change this down to 2 and make that false. Okay, so now this is a test that is going to fail. Okay, probably. Good. Okay, but notably, it has a time.sleep in there. Okay, so that means it must wait 2 seconds to complete. If it runs, it must wait. And in fact, it was 3 seconds before I changed it. So I can throw away that change, run it again, and actually you see it's completed immediately. Okay, so what can you conclude?
It's cached based on hash.
Yeah, it didn't run the test, right? It didn't need to, because it already has run it and already decided. Now, there's reasons to get very happy about that or very upset, but it's at least a thing you can do if you choose to do that. Okay. Any comments about that?
That's why the verb is flake, because if test is flaky, it can
No one knows why the verb is flake. I think it's better to not discuss it. Anyway, what were we even talking about, right? Like, we wanted to do this quine-relay thing. We wanted to get a whole bunch of packages. Our question was like, were all the packages in Nix? Actually, almost all of them were in Nix. 95 are in there, 33 were not. A lot of the no packages were kind of just included as so-called vended source code within the repository itself, or otherwise, I think the mate himself implemented a few in Ruby by hand. Good on him. Some had to be so-called patched, and I will just, I will just quickly show you what patching looks like, I think, because this is a really, I wonder if I have a patch in here. I don't. But the point is that, like, when you do a build, you download the source code, you prepare to run the file. You might want to make some changes before you perform the build yourself. So you have the opportunity to do that. The only two that really presented an issue were one that kind of required a so-called FSH environment. Does anyone know what that is?
Fish.
No?
The terminal environment.
Nope. I wouldn't I
It's
didn't
like
know.
SSH but better.
Nope. It's basically the fact that on Linux, like, all your stuff lives in these folders that I almost called them Linux Torvalds, decided at some point in time, right? So they decided programs live here in user/bin/env, and, like, I'm going to find this particular thing here. This is, of course, a huge crime, right? And so Nix has kind of undone that decision. But some programs you have to patch because they just expect that, and it's just too hard to change it. And yeah, I won't bore you with the details here, but, like, I'm not going to lie, for like 26 years of my life, I thought GCC was the name of a compiler. In fact, it is the name of a monorepo which contains compilers. So it's called the GNU Compiler Collection. I learned that literally 4 weeks ago. So that was really the only two that were problematic. So obviously I did it, right? So what we have here, over here, is if I run Nix build, well, you're not going to see anything because I already built it. Isn't that the joy, right? And so in here you can see basically all these different programming languages, like the kind of conversion steps between the programming languages. And actually no one said this, but the programming language I wanted to see the picture of was this one called PA. Has anyone heard of this programming language? I'm not looking at you, so you're going to have to tell me if you've heard of it.
It's visual.
It's a visual programming language. The source code is a picture. What? Isn't that cool? What does it look like? It looks like that. If I can, there we go. Wasn't that fun? I did all that work just to learn that. Wasn't that cool? Huh?
You can do an audio wave.
Yeah, exactly. And the other cool thing you could do is that's kind of fun to do here is, like, you're like, not bad, I don't mind this program, right? But actually I'm pretty sure this should have been a 4. Going to rebuild that. And what you should see here is a kind of so this goes to your question, right? Is now something upstream has changed. What did the 4 prevent it from doing? Is it something to do with Rust? Maybe. Seems that it is, yeah. Yeah. Yeah, basically one step along the way will no longer work. And that, it claims, is the Rust to Scala step. Okay. So then we had a look. I've got some articles about this. And maybe like a natural question is, are there any downsides to using Nix? No. Here's my simple answer there. And that's it. And what I kind of want you to feel is what one of my LinkedIn friends commented when I posted that I was going to give this talk. When I said I was going to do 128 languages, his comment was like, only 128? So yeah, that's it. Thank you.
Any question, guys?
Yeah, I have one.
Please.
So how does it solve the problem with flakiness of the test?
How does it solve the flakiness of the test? It does not address test flakiness. Basically, like, maybe you're wondering, maybe your question is like, suppose my test is probabilistic. Is that
I can rephrase. So let's imagine you have like this tool dependency, yeah, and it's like buildable in 50% of the times. So like 50% of the times it's buildable, 50% of the times it's not. So potentially what will happen, like it will cache the the successful or failed version. It will count as like successful or failed, but in real life it's flaky. So
yes, I propose to you that that would stress me out. Like, to put it another way, the whole game here is defining very clearly all the things your program or test or whatever depends on. And if it's pure, like if it only is a function of its inputs, right, that's a perfect use case for the non-fixed output derivation format of Nix, where it's only dependent on its inputs. Every time you give it the same inputs, it gives you the same output. Perfect candidate for Nixification. If you're saying there's some chance that it might do something different, what Nix asks of you is like, okay, fine, give me a hash, right? You can see that like it depends on GitHub. Maybe one day I buy github.com, right? Microsoft forgets to renew it. I own it now. I can do whatever I want, right? I can return any kind of package I like. But what's going to happen to you is merely your Nix builds will refuse to continue. So I'm trying to say to you that you basically don't enter that world, if that makes sense. Yes.
I was quite surprised to see you chatting about tests, and because like this really broke my mental model of what Nix does and does not provide. And I saw that you had a sneaky little Python decorator in there, which maybe came from Nix. And could you just explain a little bit more how Nix sees itself as a test runner?
Yes, I would say the thing that I've done here, considered maybe moderately not massively idiomatic in the Nix world, but what I think is interesting is like probably all of us have experienced intense frustration waiting for tests or rerunning tests that we know we're going to complete because nothing has changed, right? So this little Mark Pure thing is some PyTest thing I came up with just to show you that if I have a test that I believe is pure, that is a perfect candidate for turning into a Nix derivation that I then only ever need to rerun if the inputs to that thing have changed. So that's like a little, maybe a style that I'm advocating for that people would adopt. Yeah, so thanks for that question, Tim. Yeah.
Any other questions, Lisa? No?
Nice. Okay, in this case, thank you guys.